Greetings and welcome to the 6.4 notes video. We are going to be graphing quadratics now. We are graphing quadratics right now when our a value equals 1. So we don't have that number in front of x squared. We will worry about how to graph those quadratics when we get to 6.9, very end of the unit. Go ahead and throw your name on here. The most recent thing we did as a class was that quadratics organizer, and that helped prepare us for steps 1 and 2 of this 4-step process. So step 1, finding your axis symmetry and vertex like we did in 6.1. This is a blurry screenshot straight from your 6.1 notes. We are going to do negative b over 2a. We're going to plug that in to find your y value. We are going to then graph with those. Actually, I don't even know if that blurry screenshot's from 6.1 notes. I don't recognize that. Not sure where that blurry screenshot's from. Then step 2, we are going to factor. Just like we did in 6.3, we gave you that table. That table's back from 5.6 because factoring is just what we did in 5.6. There's that table. It's also a blurry screenshot of when we are going to use positive and negative numbers when we are factoring. We've got 2 new steps for 6.4. We are going to find our y-intercept. That is new. We plug in 0 for x, and then your y-intercept always just ends up being your c value in these problems. So it actually is really easy because it's just your c value. When we do ax squared plus bx plus c, it's just your c value for a quadratic in standard form. So that step's new, but you really don't have to do any work. You just have to know that it's your c value. And then the last thing that is new is we're going to put it all on a graph. So you're going to graph your axis symmetry and vertex, you're going to graph your zeros, then you're going to graph your y-intercept, and you're going to mirror that y-intercept so that it's nice and symmetrical. So we've got 5 points total. So you'll have your vertex, your 2 zeros, your y-intercept, and your mirrored y-intercept. So that is the plan for today. We've got 2 full examples, and I believe your assignment has 4 problems on it, maybe 6. I don't remember how many I squeezed on there. Okay, so first quadratic, we've got x squared minus 6x plus 5. We are going to always start by writing down our a, b, and c. Our a value is 1, our b value is negative 6, and our c value is 5. We're going to find our axis of symmetry, which we abbreviated to AOS here, just because we cannot fit the words axis of symmetry 1,000 times when we're trying to fit so much else on a problem. We are going to use the formula negative b over 2a. So plugging into that, negative b is going to be negative 6 over 2a is going to be 2 times 1. Negative 6 is positive 6. 2 times 1 is 2. So I've got 6 divided by 2, which is, sorry, I scrolled accidentally with my hand, 3. So that is the x value of my vertex. We are now going to plug in that 3 for x, and we're going to solve for y. So we're going to do, let's change colors, 1 times 3 squared minus 6 times 3 plus 5. Okay, 3 squared is 9, 1 times 9 is 9, minus 6 times 3, so that's minus 18 plus 5. 9 minus 18 is negative 9. Negative 9 plus 5 is negative 4. So that gives me a axis of symmetry at 3 and a vertex at 3, negative 4. And we're going to go ahead and graph both those things. So my axis of symmetry is an imaginary vertical line, so I'm going to graph it as a dotted line. So that's going to go on my graph at the vertical line x equals 3. Then from there, we are going to graph my vertex, which is going to be a point along that line. It is the ordered pair 3, negative 4. So I'm going to go ahead and put a point at 3 over, down 4, put a point there. Okay. That is my axis of symmetry, and my vertex, that's the bottom middle of my graph. The next thing I'm going to find is my zeros. My zeros can be found by factoring. So I'm going to be factoring out my original problem. I'm going to rewrite it here. X squared minus 6x plus 5. So I'm looking for two numbers that multiply together to be 5. They need to add together to be negative 6. Numbers that multiply together to be 5 and add to be negative 6 are 1 and 5, make them both negative. And then they'll multiply to be positive, add together to be negative. So my factored form is going to be x minus 1 times x minus 5. And then my zeros are going to be the opposite of that. So if I were to set x minus 1 equal to 0, I would add 1 to both sides. 0 would be positive 1. X minus 5 equals 0. Add 5 to both sides. My 0 would be positive 5. Oh, sorry, I keep scrolling with the side of my hand. Okay, so now that we have those zeros, those go on our x-axis. I think back in 6.2 maybe, I said that zeros, x-intercepts, solutions, those are all terms that are used interchangeably. So those go on our x-axis as our x-intercepts. So we're going to put a dot at 1 here, a dot at 5 right here. And if you notice, those will always be equal distance from the axis of symmetry, because our quadratics are going to be a nice even U. They're not going to be like wider on one side or the other. Okay, the last thing that we're going to do is we're going to find our y-intercept and graph it. So our y-intercept is always going to be our c value. On this first problem, I want to show you why it's our c value. If I were to plug in 0 for my x value, I would do 0 squared minus 6 times 0 plus 5. Well, 0 squared is 0. Negative 6 times 0 is 0. And then 5 is still 5. So 0 minus 0 plus 5 is 5. So your y-intercept is always going to equal c. So if you want to put a note to yourself in your notes, it's up there right here that it's always going to equal c. But not many of us go back and look at all of those words. We look at our examples. So we are going to go and graph that. Our y-intercept is at 0 over 5 up, so that is right here. And then the last thing that we need to do is you need to mirror that to the other side of our axis of symmetry. So that's why we put our dashed line axis of symmetry on our graph, is because we need it now. So that is currently 3 to the left. So 1, 2, 3 to the left of my axis of symmetry. So I'm going to go 1, 2, 3 to the right. And I am going to put a point there. And then by the time you're done graphing, you should have 5 points. They should make a nice even-shaped U. And you are going to connect them together. You want to connect them into a U shape, not a V shape. We're going to be looking at the points more than the connection to make sure that we can still see the points back behind where you connect. Okay, so it's a lot of things, but this is why we learned how to do 6.1 separately from learning how to do 6.3, and then we reviewed them together before we put it all on a graph together, because we know that it's a lot of things, but we are over 3/4 of the way through the school year. We're at the point where we're learning very multi-stepped processes. Right, we've got one more example of all of this, and you guys have all of your examples from 6.1, all your examples from 6.3, and all your examples from the quadratic organizer, and then you'll be able to work on your assignment, and you can use all of that stuff. Okay. Second and final example, we've got x squared plus 4x minus 5. My a value is 1. Got a 1 right there. My b value is 4. My c value is negative 5. My axis of symmetry is always the same formula, negative b over 2a. Negative b is going to be negative 4 over 2 times my a value, which is 1. So I've got negative 4 over 2. Negative 4 divided by 2 is negative 2. I'm now ready to plug that in to find my y. I know my x value is negative 2. So plugging that in to find my y, I've got 1 times negative 2 squared plus 4 times negative 2 minus 5. Negative 2 squared is positive 4. 1 times 4 is 4. Plus 4 times negative 2. 4 times negative 2 is negative 8. I've got my minus 5. 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. You guys can wait until the end to graph everything, or you can graph it as you go. I like to graph as I go, so I can make sure things are like lining up correctly. So I'm going to go ahead and do that. Graphing my axis of symmetry, vertical line at x equals negative 2. And then my vertex is at the ordered pair negative 2, negative 9. So right here. Okay, now I am ready to find my zeros. So my original function, x squared plus 4x minus 5. I'm looking for two numbers that multiply together to be negative 5. They need to add together to be 4. So numbers that multiply together to be 5 are just 1 and 5. How I multiply to be a negative is that one of them needs to be negative. And how I make them add together to be positive is I make the bigger one stay positive. So I'm going to make the little one negative here. So my factored form is x minus 1 times x plus 5. So that means my zeros are the opposite signs of those numbers. So x minus 1 equals 0. I would add 1 to both sides, or I could ask myself, what number minus 1 equals 0? 1 minus 1 equals 0. And then x plus 5 equals 0 when x equals negative 5. Okay, going ahead and graphing those. My zeros are at positive 1 and negative 5. If you guys notice, that's 3 to the right of my axis of symmetry and 3 to the left. Okay, last thing is my y-intercept. We talked about this on the last example. Our y-intercept is always c. So if I were to plug in 0, 0 squared plus 4 times 0 minus 5 would just be that negative 5. So it's just my c value, it's just negative 5. So I'm going to go ahead and graph that on my y-intercept at negative 5. And then I can go ahead and reflect that or mirror that to the other side of my axis of symmetry. That's currently 2 to the right, so I need to go 2 to the left and put a dot right there. Okay, I'm going to go ahead and connect all that together in a nice U-shaped parabola. And that is it for 6.4 notes.